In this lesson, we're going to look at some of the basic skills and terminology that we'll need as we move into algebra and solving equations. The first definition is a variable, and a variable is a symbol or a letter that stands for a number. Often we use variables such as x or y or n as letters that represent a value that we are trying to solve for. Another example would be in this formula, c equals pi d. C and d are variables here, representing circumference and diameter of a circle. And the letter pi, although it is a letter, actually is not a variable here because it does represent a fixed value, which is approximately 3.14. When you see pi d, so two variables beside each other or a number and a variable beside each other, that actually means pi times d. Okay, so multiplication is meant even if you don't see a dot or the times symbol. So for instance, 3x actually means 3 times x. And just as a little note to make sure that your x's don't look the same as your times symbol. So now let's look at what a term is. A term is a number, a variable, or a product of a number and a variable, and possibly more of them, separated by addition or subtraction. So I'm going to write down an expression for you, and then we'll look at the terms that are in it. So here's an expression, 5x plus 2xy minus 6. So there are three terms here. The first term is 5x, the second term is 2xy, and the third term is x, although you are 6 rather, but you could think of that as a negative 6. So this expression, negative 2x squared, there's just one term there. So 3 terms in this first one. Okay? Now a numerical coefficient, and often we just call it the coefficient, is the number that's multiplied by the variable. So in the above examples, we have 5 as a numerical coefficient, we have a 2, and we also have a negative 2 in the negative 2x squared as our coefficients. Like terms are terms that have exactly the same variable and exponents. And if there's more than one variable involved, all of the variables and all of the exponents have to have the same number. So let's take a look at the first example here, 6x squared. I'm going to circle it in blue. If you look at the other terms listed here, think about which ones would be like terms. And although there's an x squared in a number of them, because they also have a y cubed, or here there's an x and a y squared, they are not like terms. The only term like the 6x squared is the negative 13x squared. All of the variable parts and all of the exponents have to be identical. I'm going to switch to red here, and let's take a look at the second term here, negative 13x squared y cubed. And the only other term that is like that one is this one that has x squared y cubed. And just as a note that when you have just an x, the coefficient is 1. So x is equal to 1x. Okay? And that x squared y cubed, is actually equal to 1x squared y cubed. But when 1 is the coefficient, we never actually write it in. And we need to know what like terms are, because like terms can be combined by addition or subtraction in order to simplify an expression. And let's look at the page to see some examples. So in this first example, I have 6x plus 7x. The terms are like terms, so I can just combine them, and I combine them by just adding or subtracting the coefficients, and the variable part will stay the same. So if I have 6x plus 7x, that gives me 13x. And that is the simplified version of step A. In question B, I have 3x plus negative 8x plus 7. This term of plus 7 is not like the other two, so it cannot be combined with the other two. So we have 3x plus negative 8x will give us negative 5x plus 7. So that is now simplified. We can't combine the plus 7, but we need to keep it so that the both sides of the equal sign there are equal to each other. And of course, our terms could involve having fractions. So I've got 2/5 x minus 2/3 x plus 7/15 x, and because they are fractions, I'll get common denominators for them. So I'll have 6/15 x minus 10/15 x plus 7/15 x. And now I can combine the numerators. So I've got 6 minus 10 plus 7, which will give me 3/15 x, or 1/5 x. And then D, we've got 10b plus 3a minus 8b minus 5c plus c. So when you have more than one type of variable with using different letters, we often agree to put the, for instance, if we have an x squared and an x, we'll always put the x squared or the higher exponent first. If we have more than one different letter, we'll often put them in alphabetical order, just so that we can all agree on what the simplified version will look like. So let's take a look at that 3a term. There's no other term like it, so we can't simplify it further, so it's 3a. Now let's look at our b terms. We have 10b and a negative 8b, or 10b subtract 8b, same thing. When we combine them, we end up with 2b, so plus 2b. And then if we look at our c terms, we have negative 5c plus 1c. So that gives us, negative 4c, or subtract 4c. I'm going to just separate those two questions out there. And here's an example of a question that we could answer using our combining like terms skills. So question E is asking us to find the perimeter of the shape that's shown here, and there are expressions for the lengths of each of the sides. And perimeter, by definition, is the sum of the sides. So we can say that the perimeter equals x plus 6 plus 5x minus 3 plus 2x plus 1 plus 3x plus 2. So now we can look at all of our x terms and combine them. So I've got 1 plus 5 plus 2 plus 3, which will give me 11x. And then we'll look at our numbers as well. I've got 6 minus 3 plus 1 plus 2, which gives me plus 6. So the perimeter is 11x plus 6. One of the properties that we need to look at as we solve equations is called the distributive property, and we'll see a lot of this as the course continues, in addition to what we're seeing right here in its relationship to algebra. The distributive property really talks about how when we multiply items in brackets, we need to make sure, or parentheses, we need to make sure that we're multiplying everything that's inside those parentheses. So in this case, 5 times, in parentheses, x plus 6 really means we're multiplying that 5 by the x, and we're multiplying that 5 by the 6. And you'll see that we often draw arrows to remind us to make sure that we're doing both multiplications. So when we multiply, we end up with 5x plus 30. And use all of your multiplication skills that you already have, watching for signed numbers as well, so that you might end up with positive or negative results. Okay? And this is the rule expressed in general terms. If A, B, and C are signed numbers, then A times B plus C is equal to A times B plus A times C. So you can see that if I drew the arrows there, I'd get A times B plus A times C. And the same works with subtraction. Just follow the rules with signed numbers. So you would get A times B minus A times C. Or you could think of that as A times negative C and pull the sign out front. So let's look at some examples of using the distributive property to get that skill down pat. So I've got negative 3 times x plus 2y. Oops. And I'm just going to draw the arrows for the first one here just so that you can see what I'm doing. So I'm doing negative 3 times x, which is negative 3x. And then negative 3 times 2y. Well, that's a negative times a positive, so my result is negative 6y. And the same thing, if you look at B, the same thing works whether what you're multiplying is after the parentheses or before the parentheses. You're almost always going to see it before the parentheses. And we always pull the number in front of the variable. So we wouldn't call that x8, we would call that 8x when we multiply. And then 8 times negative 2y will be negative 16y. And we could possibly have to use our distributive property with fractions as well. So I've got 3/4 times, in parentheses, x minus 1/2 y plus 2/3 z plus 8. Again, with all of these, you should perhaps be pressing pause and trying it yourself before moving on and pressing play and seeing if your attempt was correct. So in this case, I've got 3/4 times x, so I've got 3/4 x. And then I've got 3/4 times negative 1/2 y, so that'll give me negative 3/8 y. And I've got 3/4 times 2/3 x, which is going to give me 6/12, which is 1/2 z. If you can get into lowest terms on your first go, you don't have to spend extra time simplifying some of the terms. And 3/4 times 8, or 3/4 of 8, gives me 6. In question D here, I've got 2 sets of parentheses, so I'm going to be very careful as I do these. Okay, so I'm going to get 3x minus 6y for the first one, and in the cases like this one with a negative 5 or subtract 5, think of it as a negative 5. Negative 5 times 2x will give you negative 10x, and negative 5 times y gives you negative 5y. And just watch your signs and notice that now all of your results in one step, you've got your sign correct on everything. And now let's combine our x's first. Because this is not in simplified form. In simplified form, we've combined all the like terms that we can. So I have a 3x and subtract 10x, so that'll give me negative 7x. And I have a negative 6y and a negative 5y, so it's negative 11y. And that's it for this first introduction to algebra skills.